In this video, we're going to take a look at how we could use the ideal gas law to find the molecular formulas of gases based on certain information and how to approach these types of problems. So let's go ahead to our handout here and take a look at the steps required to find the molecular formula and molar masses of gases. So we have our two main steps. It's basically find the number of moles using PV is equal to nRT first, and afterwards do mass divided by number of moles, because that's grams per mole. That's your molar mass. There is another formula you could use that I'll show you later on how to derive. But right now I'm just going to show you how to do a problem using these two main steps here. And then I'll show you how to derive the molar mass formula from PV is equal to nRT. So we have a 1.10 grams of an unknown gas occupies a volume of 567 cubic centimeters at STP. Calculate the molar mass of the gas. Based on this molar mass, is the gas O2, F2, CO, or CO2? Explain your answer. So there's a lot there. There's three main parts to this question. Find the molar mass of the gas, identify the gas, and explain your answer. Three main parts. Let's write out some information that we have. We have the mass is equal to 1.10 grams. We have the volume is equal to 567 cubic centimeters, which is 567 milliliters, because 1 cubic centimeter is equal to 1 mil, which is equal to 0.567 liters, because we're going to be using PV is equal to nRT at some point, so we need to be in liters. We have our temperature given to us as well. Remember, temperature is at STP, so we have 273.15 for our temperature, 273.15 Kelvin. 273.15 Kelvin. And we have a pressure at STP is 101.325 kPa, as well as the R value of 8.314 with all its units. And so remember that we want to find the molar mass. So the molar mass is going to be your mass divided by your number of moles. And where does this come from? Well, this comes from, remember, up here, if we had mass and we had moles and molar mass, if we want to find mass, we would do moles times molar mass. So if you wanted to find molar mass, you simply do mass divided by your number of moles, because it's grams per mole. And students would wonder, well, why don't you just go to the periodic table and calculate your molar mass from there? Well, we don't know what our molar mass is. Remember, we don't know what a gas is. It's an unknown gas. And that's what we're trying to figure out. So we have to find our molar mass through a formula this time. So really, we need to find our number of moles, and then we can figure out what our molar mass is. So to use this formula, I need my number of moles from PV is equal to nRT. We already have mass. I just need my number of moles. So I know that PV is equal to nRT. So that means my number of moles is equal to PV over RT. And so that's going to be my pressure, which is 101.325 kPa, multiplied by our volume, which is 0.567 liters, divided by our R, which is 8.314 kPa liters per mole Kelvin. And then by our temperature, multiplied by our temperature there, 273.15 Kelvin. We can cancel out Kelvin, we can cancel out kPAs, we can cancel out liters, and in the end, we're left with moles, which is what we're looking for. So 101.325 times 0.567 divided by 8.314 divided by 273.15, and we get 0.025298131 moles of that unknown gas. So now that we have our moles and our mass, we can find our molar mass by doing molar mass is equal to mass over moles, which is going to be the 1.10 grams over 0.0252, so on and so forth, moles. All my digits are still in my calculator, though. So 1.1 divided by that, we get 43.48147208 grams per mole. And so we can also put this to the appropriate number of sig figs. It looks like 3 sig figs is what I want. So it's approximately 43.5 grams per mole. Now, in this question, this is our first part. We found the molar mass. So I'm just going to go ahead and call this A. Molar mass is equal to 43.5 grams per mole. So I'm just kind of summarizing my work. For B, I had to identify what the gas is. So this was part A here. Let's call this part A. Part B. For part B, I have to see what the gas is. So really what you're doing is you're going to find out which of the gases have the same molar mass as the molar mass you calculated. Molar mass of O2, you know that's 32.00 grams per mole in the periodic table. Molar mass of F2, you know that's going to be 38.00 grams per mole from the periodic table. Molar mass of CO, so that's your 12.01 plus your oxygen, 16, is 28.01 grams per mole. Okay. Now I'm doing all this very slowly, showing you, what all the molar masses are. In a multiple choice, you can go a bit quicker. You can, if it's not oxygen, fluorine, and carbon monoxide right off the bat, you can just go for your last one. I'm assuming this one works out. So molar mass of CO2 is 32 plus 12.01. You get about 44.01 grams per mole. Now, nothing is exactly right on your molar mass that you calculated in the previous question, but choose the one that's closest. So the one that's closest is the CO2. So the gas is CO2. CO2. And then for part C, the unknown gas has approximately the same molar mass as CO2. And that's the explanation, the reasoning behind why you decide to choose carbon dioxide as the unknown gas, because it had a very, very close molar mass, a very, very similar molar mass to the unknown gas that we calculated. There might be some measurement error, which is why we're not exactly, at 44, but we're pretty close, considering everything else is farther away from it. So this type of question was a bit different. You had to find your molar mass by finding your number of moles first and then doing your mass divided by your moles. There is a formula you could use to find molar mass from the PV is equal to nRT. So here I'm going to show you how to derive it. So remember that we have PV is equal to nRT. So the number of moles is equal to PV over RT, right? Because you're just isolating by sending RT to the other side. Now, remember that your molar mass is equal to, as we said before, M over N, mass over moles. So let's do that. Let's take this equation here and replace this mole value by this, because they're the same thing, right? PV over RT. So we're going to replace that. So we're going to have molar mass is equal to M over PV over RT. Now, if you're fairly decent with math, you'll know that if you have sort of a division over a division, this now comes to the top. So we're going to get molar mass is equal to mass times R times T over PV. So this is a formula that you could use to find the molar mass of your unknown gas. And technically, all this long work we did here was exactly that. We did all that work there to do exactly this. So just to show you, if I want to do this to get the same answer, so this is just an aside here. Okay, so this extra bit I'm doing as an aside to show you it gives you the same answer. So we're going to have our molar mass is equal to our mass, which is 1.10 grams times our RT, so 8.314. I'm not doing all the units there right now. Times the temperature, which was 273.15 Kelvin, and then over the pressure, which was 101.325 kPa, and then times the volume. The volume was 0.567 liters. If you do all that in your calculator, you should get the same molar mass we got there. So 1.10 times 8.314 times 273.15 divided by 101.325 divided by 0.567, and you get 43. So 43.48147208 grams per mole. And you would actually have moles left over. So if I put the units in here, you'd have grams left over. You'd have moles left over in here as well. So you'd have grams per mole at the end. And that's what you'd end up with. And it gave us the same answer as the long method we did here. So the long method shows you the logic behind it. This formula here is just more of a, here's how you would do it in one step. But it's important to understand, how you get these formulas, how you can derive them, right? So if you didn't know how to derive a formula before, now you know how to go from molar mass is equal to mass over moles to getting this over here, because the moles came from this formula here. And when you plug it in, you can rearrange it and get your molar mass formula like that. So either one of those methods works out. You can use the formula directly or the long steps, and you can solve your problem either way. So in the next video, we're going to take a look at figuring out the molecular formula of a gas. So this type of problem here was the molar mass of a gas, and we use the molar mass to find the identity of the gas. Next, we're going to go ahead and try molecular formula of gases using these good old percentages that you might remember from back in Unit 3.